Hello, hello. What am I doing? I'm doing the thing I always do when I start a stream. I turn off all of this previews sent back to me. Not now, LastPass, not now. Oh, my audio is coming out of somewhere. Always a pleasure, right? Watching me get everything going. All right. Hello, everyone. I'm going to get going in just a little bit. I like to start a couple of minutes early just to make sure everything's set up. I think I correctly changed the titles of everything. I've got Discord open, and I've got Restreams chat open, and I don't actually need the YouTube chat. So yeah, if you're everything's are working, please chime in on your chats or all the chats. Let me know you can hear me, which I think you can. And yeah, let me know. Say hi. I'm in Discord. Here we go. Looks like we have 11 folks watching on YouTube. Abominable says hi from Discord. I know there's usually a lag. I do have the stream on YouTube set to normal latency, so that might be part of the problem. Is anybody in the YouTube chat? I'm kind of surprised I haven't seen anything. Can you not hear me? I could hear myself through the stream, so I know my audio is working. I hope you all are excited about this stream. I'm excited about this stream. I've got some really neat stuff that I've been doing. Ah, there's Mark on YouTube. Thanks for jumping in. Mr. certainly must be busy. He's usually helpful in posting to all the chats as well. But we don't have to wait for everybody. Can get going in just a minute here. Once we collect a few more people, I don't know. Hi, Rosh. Thanks for joining. Hopefully next week I'll have a better camera. Oh, thanks, Arash. I'm glad you can hear me. Well, yeah, I have this existing Sony camera that I've had for a while, and I don't use hardly at all. But I think it can do clean HDMI out, so I'm actually planning on... I'm getting a capture device, so hopefully I can use that and get full 1080p picture of me instead of this 720 Logitech one, even though the thing says on it 1080p. Like, that doesn't work with Mac for some reason. Oh, Mark, you're ahead of the game, as always. Thanks for chiming in. Okay, as you know, Leonardo says hello from Twitter. Which Sony is it? Mark asks. It's an RX 100 Mark III, which I think is like the very first one that can do it. I've had it for a while, and it takes great pictures, so I'm excited to try it. I need to make sure I have like a mini HDMI to a regular HDMI cable. Hi, Jim. Awesome. Sweet. Okay. Folks are showing up. And I'm seeing it. Hopefully I won't forget about the Discord window like I did last week or the week before. Okay, let me show my my screens briefly, and then we'll get going. Actually, let's Get that out of my face. Okay. Hello, everyone. My name is Scott, and I work on CircuitPython for Adafruit. Adafruit is an open source hardware and software company making hobby electronics based out of New York. I work remotely, so I'm actually in Seattle here. And I do these streams every week. They're called deep dives because I tend to get into the weeds of technical discussions. I'm kind of like one of the the lead core developer of CircuitPython. I'm the first person that Adafruit hired to work on what became CircuitPython. So I get into the weeds and do the nitty gritty stuff. So I do these streams at 2 p.m. Eastern, not Eastern, Pacific, 2 p.m. Pacific, 5 p.m. Eastern every Friday usually. I do if it's a 3-day weekend in the U.S., I'll shift it to Thursday at 3. So just keep an eye on the Adafruit blog, and I post there. I try to post like 24 hours ish beforehand to let people know. You can always ping me on our Discord. I'm happy to answer when I'm planning on doing stuff there. If you want to join our Discord, you can go to the URL adafru.it/discord. I think it's down here. Will work as well. And I should also say I am paid by Adafruit, so please go to adafruit.com, buy stuff there. It supports me and a lot of other cool people doing a lot of really awesome open source stuff. So let's see. The only other thing I think I do for housekeeping is the cat. I have 2 cats. One cat is epileptic. He does have seizures from time to time. He actually had one earlier though, so it's really rare for him to have 2 in one day. So he should be fine. But if I do hear hissing, I will actually just pause and let him finish and make sure he doesn't hurt himself, and then I'll join again. So just a heads up. It may seem weird that I say that, but it has actually happened since I started doing these streams. So that's what's going on. Arash says, I'm in Washington State and used to work for Microsoft. Awesome. Yeah. It's really not that nice of weather today, but it means that I'm not super hot. For those of you keeping track, I have a full glass of water I can spill on my keyboard instead of a bunch of ice water. And Bruce is saying that the Google captions are really cool. Yeah, my wife actually works for Google, and I was telling her how awesome the live captioning is for accessibility. So hopefully it doesn't get me too wrong. That's the cat. So the deal today, or the plan today, is I typically stream for about 2 hours. So if I'm in the groove like I was last week, I will actually go longer than that if I'm in the feeling up for it. But typically I shoot for 2 hours. And what my plan is to recap what I've done this week. And I think that's going to take a little while because I've done a lot of really interesting things, and I think there's a lot to talk about there. So we'll do that. And then I think because I've done a lot of relatively small pieces, I need to just make some PRs and start getting these changes merged in. Hopefully I'll get you excited about the changes I'm making as well. And then we'll go from there. Deland says, hello, fellow Washingtonians. Awesome. I guess Pacific time zone's better because if people are later, then they're done with work and things like that. Bruce says, I moved to Discord for now, and the weather north of Washington State in Canada is very nice today. Lucky you. It's cloudy and not that warm, but it means it's great for closing the door in the office here. Okay, so that's the plan. I know it was kind of vague, but Bruce's bar for weather is very nice. It's 3 days in a row with no rain. That sounds like Seattle. Mark says the weather further east in the prairies is less nice. The thunderstorms today have been crazy the last couple hours. Nice. We rarely get thunderstorms. Okay, so where did we leave off last week? We left off with the optimization to the JSON stuff to I was changing the native JSON module in CircuitPython to accept any object that had the read into method. And we made a PR, and I didn't want to test it. But if we just pull that up, we can take a look at it. It was actually just merged in, which is great. So if you want to try it, that piece of the puzzle has been merged in. On the ESP32S2 stuff, oh wait, you can't see my screen. There we go. On the ESP32S2 side, Jeff did a couple improvements already because he was trying it out. One, he made the microcontroller's unique address actually readable, or like it put it to use. So that means that like the USB serial number will be different for every device now, and just if you do like microcontroller.cpu.uid, it'll be different now as well and stable. And then he also changed the way that the make files call out to Ninja, so that you can do the -J to get parallelism out of make, and it will work, which is cool too. And then this is the PR that I made last week. Add support to JSON.load for any object with the read into. It turns out I actually broke the unit tests after the stream. And so I fixed the unit tests and added another one as well. So if we just look at the files changed, here's the things that we changed, where we have this wrapper C method that calls back out into Python to call read into. And yeah, so I added another test here, micro.json load read into. And this just uses a buffer here that has a read into method. I did actually test it as well, as if an exception is raised in this read into, it does like get caught and handled, and it's pretty good. But yeah, I broke the test because I had a bug where the bug was that I stopped setting this JSON stream object to all zeros to start. So I had to explicitly say error code and current to 0. To actually fix the tests. But that's checked in, and I did get socket using it. So one thing that threw me off, so this is the recap portion of everything. And as always, if you have questions or just questions at all, just put them in the chat. There's a bit of delay, but I'm happy to answer them. One of the things that I realized, I don't know if I realized this before or after the stream, but so, like Python search is just so terrible. Like docs, yes, I want to search the docs. I don't want to search the peps. I want, like, even if I use DuckDuckGo, it's not great. Like it gives me 2.7 first. So I keep clicking the 3 ones. So the challenge with using socket directly is that it doesn't actually have read into. I don't know if I commented about this on the stream last week or not, but yeah, it doesn't have read into. It has receive into. I just find it, which is different, of course. So I was like, oh, well, I try to be really strict in my APIs that are mirroring APIs of CPython. So I can't just add read into, because then if I like use a CPython socket, it won't work either. So what I ended up doing, and I was then like the layer above that is requests. And so if I looked at the, let me know if the stream has problems. YouTube is complaining a little bit about bitrate. So what I'm actually doing is that like request is using the JSON module. So the question is like, does requests have, oh, come on. Like it's not waiting for, it's waiting for DuckDuckGo. It's not even waiting for the site to load. Like, come on. Oh, is my internet crapping out? Uh-oh. Or Python request is not working. That's not good. I'm a little scared I just lost internet. If you can see me on the stream being worried that I lost internet. I think I did. Why does OBS look okay when my internet and my Discord doesn't work? Ugh, really? Worst timing ever. Oh, interesting. So Benjamin says you haven't lost internet for me at least, and Dylan says I can see you on stream, but Discord went down for me. Mark says I stepped away for a moment, but I still see you. Okay, so Discord's not happy. Why isn't my help.github.com working? Like OBS looks okay, and I'm seeing your chat. Okay, Discord's broken. Gambler21 says Discord's down too, but GitHub is not working for me as well. Which is, I mean, I can do without it. Like I can just skip the web stuff. Can you go to GitHub, or is this like a Cloudflare outage or something where it like hits half the internet? I'm glad you can still hear me. I'm sorry that I'm getting distracted by the fact that like everything is crashing, or I'm like unplugging from the internet. You're my lifeline to the internet, to the outside world. Bruce says Discord's broken. Yeah, Discord's just spinning for me now. Mark says I can get help.github.com. What is the deal? Why do you think that is? Why my browser's not happy? YouTube works. My wife just texted me saying I'm having trouble getting Wi-Fi to work. I am streaming. Dylan says Discord works. Has your DNS died? Yeah, it kind of seems that way, doesn't it? I thought I was using... it's possible it's our router. But I mean, if Discord's broken for... Yeah, Discord's broken for other people. Victor just joined. Like half the internet's not working, but apparently the stream still is, but it's not working for my wife either. But like I've streamed when she's been working just fine. Let me pull up our router and off screen here. Just see if it's complaining. It says the network is bad. Access point, retry rate. Like, we have gigabit internet. It shouldn't be a problem of like I'm taking all the bandwidth. I just think that like there's got to be some sort of internet issues right now. let me run a speed test while I'm streaming. Maybe it kind of seems like the DNS is unhappy. Mark, I got your Discord ping on my phone. Because I got the ping, but not the not in the Discord app. Yeah, it kind of seems like my DNS is down. Which would make sense. My router buffer is full. I restart my router every day. Yeah, Charles is hardwired and cannot get Discord. Yeah, my cell phone is just trying to load. Paul really wants to send an IT crowd gift so much right now, but Discord's down, so he can't do it. I think my DNS requests are to like the Google one or the cloud. It's the Cloudflare one actually. I think, which is it all ones? Sorry, my wife's working from home obviously too, so. Da, 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 da. I mean, so I might stop the stream if I have to if her team meeting is. Are there any other sites that aren't working for folks? Oh, okay. Okay, she's got a meeting at 3:30, so I think what we should do is just like I'll do as much as I can. Like you can still see and hear me. I'm just recording me debugging stuff. Yeah, 8888 is down. Yeah, I don't know what. Let me see what I have it set to. In my router settings. Anybody know where DNS is in Ubiquity? Routing and firewall. I think it's under services actually. I don't actually know. Where do I set it? Let's all move to PictoChat. Benjamin says work from home life where just connecting to the X to shade them is half the problem. Jim can still get to localhost, which is good. All right. We're all hanging out. Matthew says Discord seemed to come back. It's all good. I can show stuff without it. The various DNS check sites appear to be unavailable. Yeah, I think there's just like an internet storm going on right now. Yeah, internet broken. Yeah, it's not just us. Mark wants me to see if I can host Discord 8.8.8.8. It's so weird. Mark can ping me on Discord, but I can't actually pull it up on my phone. Did Google just buy all the bandwidth and give it to YouTube? Maybe. I don't know if any of my other streams stopped. Mr. Certainly says early reports says Cloudflare issues, DNS and routing issues. Not so sure, but it's happening on both East and West coasts. All right, well, yeah, that doesn't surprise me. I think I said that like right as this started of like, oh, this is probably just a Cloudflare where they take like half the internet down because half the internet goes through Cloudflare. Yeah, 8888 didn't work for the discord.com domain. All right, well, you know, the stream's already going. If I have to restart, maybe I won't be able to start, but y'all can hear me. I got lots of changes locally that I need to push to GitHub, which I may not be able to do right now. But let's go over those. Let's stop worrying about it too much. I thought I was set to 11111. It's fine. I don't need the internet. I can program without the internet. It's weird. It's kind of unheard of. But yeah. I can still stream. I got lots of code locally. Okay, so where were we? Okay. We were talking about the fact that Socket doesn't have read into, which is what I just made work with. So let me pull up the library side. Yeah, Matthew points out that the push notification to your phone will be through Google, so it works even without you being able to access Discord. Yep, exactly. Yeah. I have an iPhone, so it's Apple, but yeah, same difference. It's so weird, though. It's like one of those user expectation things that just doesn't make any sense. Yeah. Okay, so let's just talk APIs. So what I found is that requests has a way to get a file-like object if you stream the request. So there's this raw attribute on a response for requests that gives you a file-like object. I'm not actually exposing it as raw, but what I'm doing is I made a wrapper. So there's this raw response class. It takes in the response. It keeps track of an offset, which I'm actually not using. I was testing some stuff earlier, so I'm just going to delete that. And then you can see here that just read into just calls response read into. I had to do this wrapper on response because have I talked about any of these changes? I don't know if I have. But basically, I'm doing this read to thing, which is using these receive buffers to like receive, like when we're looking for a line or like up to a certain character sequence, like I wanted to buffer until I found it and then return it back. And what I found is that like there's some trickiness with doing read into is like I can't directly call to socket because I may have started to buffer the things that I want to return from the file like object. So I've got this read into here that is doing some fill up stuff that I've already buffered. And then once I'm out of stuff that I've buffered, then I just call socket receive into directly. So you can just trust me that that works. I don't think that's actually the most interesting thing that we're going to talk about today. Um, there's also this throwaway stuff, and I just need to go over this class and the socket stuff and pull out the stuff that I don't actually want in there anymore. Um, but yes, so and yeah, I guess if my stream does fail, ping me on Discord if you can. It'll hit my phone. I just won't actually be able to reply there. Um, Alvaro said in YouTube chat, "Git push over floppies." Okay, so I've basically plumbed into the JSON stuff that I added on Friday, and I wanted to see, like I basically have two examples. I've got Feather M4 on my desk here that you can't see that is got an airlift feather wing on it, and I wanted to compare. The goal with the rewrite stuff was twofold, right? Like fewer allocations and fewer large allocations. And so I think I discussed it, but I'm basically adding a new module to CircuitPython that does two different things. So let's talk about that. This is not what I want. So I'm introducing this memory monitor module, and its goal is to provide better insights into CircuitPython's what's happening for a segment of CircuitPython code. And there's two classes that I've added to this so far. The first one I added was this allocation size, and I showed these off on the show and tell, so that they're not super secret. Allocation size, and its goal is to count how many allocations within certain bucket sizes occur within a given piece of Python code. And I did that originally, and I showed this off on show and tell, and I was like, it was like a few thousand for, actually, I could just show it. Let me, instead of trying to recall it, let me actually show it. Okay, so I'm plugging in, actually, I need to load a new version of this, so let's do that too. I fixed some issues with it, but let's just show what I've got here. So I plugged in the one that has all of the old versions of requests and socket and ESP32SPY. And let's take a look at the code.py. So in the code.py here, we're now importing memory monitor. So like the goal with this is to leave the libraries the same, but it does have like a brand spanking new version of CircuitPython under it that has this memory monitor stuff. And so we're doing the initial setup. We do the old style sockets thing. We connect to the access point, and we might actually have problems connecting. Can we go to adafruit.com? Does that work? I mean, I guess DNS is broken, right? I didn't think about that. We might have to do a dummy example or something. Let's just see what happens. So it can find my Wi-Fi. Mr. Certainly says adafruit.com is broken for them. There's my IP. Oh no. Oh, this is so funny. Okay, well, Mark says it's working for them. I don't know what DNS server the ESP32 spy code actually uses to get it. Well, that's a bummer. Do I have... I don't think I do. I had like a copy of the counts. So, sorry. You'll just have to take my word for it. But basically what I found is that um, it was buckets. It's by blocks. So when CircuitPython allocates memory, it's minimum 16 bytes at a time. Um, ooh, actually, I could actually change that. Um, IP lookup. Close that and Wi-Fi test. That may not. This may not actually work, but 104, 20, 39, 240. Charles Burniford can't get to Adafruit. Bruce says Twitter is buzzing about DNS issues. Maybe the the internet apocalypse. Okay, let's comment that out. Let's see if we can't get it going. It's not the end of the world. I can just tell you how amazing my code is. I don't actually need to prove it. Oh, 605 in ping. Sure, I'll just pause it. It's the memory monitor stuff that I really want to show. So, yeah, perfect. Here we go. Well, it got me an error code. Dear, what should I say? Dear stream watchers, DNS, could you also tell me the IP for CoinDesk? That the problem is that, well, I guess it's HTTP. I need the IP for api.coindesk.com or some other server that will give me some JSON. This is the world's best DNS. 998661. Thank you, Mark. Jim says stuff is back up. Oh, is it coming back? Right Direction says, can I ask you what you are doing with this much coding thing? I came from watching your Firewalker Shoes project. Oh, Mark gave me a... Latency to Mark DNS is kind of slow. It's true. Oh, well, we got something back. Mark gave me a different IP address than what Mark gave me. We really don't have to keep doing this. This is really not. 24379. Let's just try this last one that Mark gave me and we'll see. Usually I would be showing how I'm optimizing the Wi-Fi internet requests from the ESP32. Oh, well, these are coprocessor spies. I've been doing a lot of optimization work and memory side, but the internet is currently tossed up in the air, shall we say. So it's not actually working, but that's all right. Okay, so basically this is the output that I'm having here. So test Wi-Fi is giving me an error code text, and that's fine. That's all I need. I just need some sort of response. So let me show you how this works. In code.py, we say we're fetching text from, and then we're doing memory monitor allocation size. Right. Deshipu says they may be using virtual hosts, in which case accessing it by IP won't work. Yeah, that totally makes sense. Paul says, please tell me one of those addresses is a Rickroll. Yeah, I don't know if there's like a Rickroll IP or not. Um, so this is how Mark gave you a different IP than Mark Fun. GeoMark DNS. That's right. I have two different Marks giving me IP addresses, and they're in different parts of the world. I feel like we could do like an interesting experiment with that. Um, okay, so this is how allocation size work, and this is actually when I wanted to say, like, big flashing lights. Um, oh, Matthew says you probably need to send a host header because those IPs are CloudFront. Yeah, I could get into that, but I'm not. I'm not gonna bother. It's fine. We can just wait till it's up. Um, let's talk optimization. And so the big flashing lights that I want to have when I'm talking about memory monitor is I want to caution against premature optimization. Those of you who've been programming for a while have probably run into this. But there is a tendency when you're doing optimizations and working with computers and doing coding to get so focused on optimizations that you lose sight of like what you're trying to accomplish, and you can spend a ton of time trying to get that last little bit of performance out when you actually like are already doing the thing that you need to be doing in the time that you're given or the memory that you're given. So there's this notion of premature optimization, which is spending a lot of time optimizing before you understand what needs to be optimized. And so I wanted to give a warning about that. Like, don't do that. Don't optimize unless you're absolutely sure that the thing that you're focused on needs to be optimized. And I want to warn about that because I think the memory monitor stuff that I have so far is actually incredibly powerful and a little scary in the sense of these numbers. So if I pull up the output here, like even though it's crashing, we managed to fetch this error code, right? So what this is telling us is this is like a histogram. So this is within this width block, these two lines, how many allocations occurred. So basically what the width block does is it turns on allocation size and then turns it off when you're done with the block. So it's counting the number of allocations that happen, within that width block. And the way that I have it working is that it basically has a series of counters, and each counter is for like that between that number and twice that number. It's like a logarithmic sort of bucket thing. So you can see here that like the first bucket, I forgot to update this, but this is like less than or equal to 1 block. And then this one's less than equal to 2 blocks. And this is less than equal to 4 blocks, etc. And so a block, as I was saying, at some point when the internet exploded, was that in CircuitPython, typically in MicroPython as well, a block is typically 16 bytes. So whenever you allocate something, mostly, it's at least 16 bytes. Now, there are a few tricks that MicroPython plays to be able to take small values and put them in the pointer itself. So pointers tend to be 4 bytes. And there's way for like small numbers and strings that live elsewhere to be counted as like kind of stored within it rather than actually on the heap. So we're ignoring those things. But yeah, so these are numbers in terms of how many allocations within this win block occurred of 1 block, 2 blocks, 3 or 4 blocks, 5 through 8 blocks, that sort of thing. And this number seems kind of high to me, a couple hundred, like 581, and just these two things. But then for this second response, which maybe I'll undo these IP addresses, and maybe if the internet comes back, it'll actually work. So we can keep trying that. But yeah, so what I was doing is I was comparing, with all these optimizations I'm doing with like reading into and all those things, how many, based on the allocation size tracking, like how many. Hey, there we go. It's working again. Um, so these are kind of the numbers that we're starting with, right? Like these are the numbers, and actually, I think I need to update this because actually I don't. Um, I got rid of clear. So width will automatically clear when it starts now. But these numbers are right. So um, these are the numbers that we should be comparing against when we're doing checking our optimizations. So I want to just update so I know that I'm using the same version of CircuitPython. So, oh, you can't see that. There we go. I was doing it with GDB, but I don't actually need to. Let's just clean and do a full build. Sorry if I get framey while it builds here. Asking my wife if it's working for her now. Thanks for hanging in with me while I lost internet. Oh, and I of course should have copied those numbers so we could compare. I'm actually curious. I made some improvements yesterday and didn't notice that, or didn't actually look at the numbers directly. So what I'm doing right now is I just want to update the CircuitPython version on this feather because I tweaked the way that the memory monitoring stuff works. Actually, I fixed it. The other thing was broken. Okay. So I'm just copying. Actually, I'll show you just a sec. So I've got this window and I have all these builds, and I just did the Feather M4 Express build. So I'm just going to drag the firmware UF2 over and flash it, and then it should pop back up as CircuitPy. Which it did. And I think it should give us an error now. Yep. That's not the error I expected though. Try it again. This is hot off the press CircuitPython. I don't think it I think I was having the trouble with this actually. I think that the current version of the library is not very reliable. Like pinging with 0 milliseconds, it's like it didn't actually finish getting the response back or something. Try it one more time. Maybe I'll add a sleep. I think sleeps can actually help get the Wi-Fi going. 10 milliseconds on the ping, but still didn't receive the full response. Like I think I was having troubles with this yesterday. Like this library was just not super reliable. Come on. Am I supposed to open that on stream? My wife dropped a package off. My birthday was a couple days ago, so I'm still getting presents. Okay, so we can see that the allocation size stuff worked, except we ran out of range, and I think that's because I have the buckets hard coded here, but I did actually make the iterator work. So, and I reduced it from 32 buckets because like turns out 32 buckets is like way more than you actually need. Hey, Discord's back. Fede2 had said, that's why I don't optimize anything. Katney says, Cloudflare and Google fail. I don't know what it is. Oh, happy birthday, GD Hamp. Awesome. Bruce says, back to the land of the GIF. Yeah, if folks want to join our Discord, it's adafru.it/Discord. And I don't know what the deal with this is. All I need is one run. And then once I have one run, I'll just copy it and we'll compare it to the new stuff. Allocation size index out of range again. 82. Oops. 82. Oops, I missed one. Bruce S. posts a picture of a quote from Code Wisdom that says, in carpentry, you measure twice and cut once. In software development, you never measure and make cuts until you run. Charles says, it's alive. Kind of amazing how that can happen, right? Amazing how the internet can go out for a lot of us. What? Didn't I fix it? Index out of range. I don't get it. Oh, it's running again. Ah, GD Hampman says, you mentioned optimizing for space and time, but didn't mention power, which sometimes is an issue. Yeah. I've only done very little power optimization, which actually is a lot more than I had before that. But, yeah, it's still not. Why is the index out of range? Oh, you know what? I think I had this problem. The iterator is actually returning the values, which simplifies this to that. And let's copy this in the other 3 spots. This is just a testing script. Okay. Didn't receive full response, failing out. Fede2 says, that's why more web things need to start moving to IPFS. What is IPFS? I've not heard of it. Didn't receive a full response again. I don't know what the deal with that is. I don't know why it's having a problem. All I want is a baseline. Come on. Just work for me once. That's why I should have saved it when I had the chance. I don't want to have to fix the old version of the library. All right. This is the last try. If this doesn't work, I'll just do the new one. I think we do have... No, it's pinging 0 milliseconds again. Interplanetary file system. kind of a weird mix of BitTorrent with blockchain. Ooh, the weather looks nice there, Mark. Outside, under like a cover. What's the definition of insanity? Does it apply to computers? Huh. So when I upload an image to a website, when people look at the image, they also share it. So it's quite resilient to this kind of things. All right, well, this is good enough for me. So for fetching, well, no, I want to do the JSON thing. I really want the JSON one because I'm really optimizing for the JSON case. And I'd like your feedback on this. Is the read into reading the whole response? I'm not actually sure. Well, it's not a read into in this case. It's a read line, I think. It has no attribute paused. These are all the things that I got rid of in the API. I had it where you could like start and stop or like pause and resume directly, but I removed that. I think I just prefer the context, like the with context only. Heyo, here's our baseline. Okay. Let's copy this and run the same example. So let's see. Okay, so simple doesn't do any allocation, which is what we want. So we really only have these two. So let's just save that off into a new file and compare. So let's disconnect and eject. And plug in the Metro here, which should have the latest code because I was working on it yesterday. So let's just run it. So these first prints are actually like how much memory it took to import, which I do want to optimize for, but I'm not worried about it right now. I have a bunch of like stuff copied in there just in case I need it. All right, sweet. So here's some newer numbers. And let's just compare. Although I think I'm splitting them out. And of course, let me edit this code up high. I was listening to Hades Town earlier today and it's stuck on my head. Let's not do this. I thought that would be easier, but unexpected maker, you're fashionably late. Definitely. Like the first 20 minutes was like the internet exploding or imploding, which turns out is kind of a problem when testing the internet stuff. Okay, so let's compare these numbers. And I know they're kind of small, but I think it's better to have them next to each other. Oh, I didn't update the first set. This set. Huh. Yes. Jeff points out that a rather different approach is also avoiding building the whole JSON object in memory. Could also have applications in CircuitPython. Yeah, for sure, for sure. So for a recap, I'm adding this memory monitor, or we might rename it something else. I don't know. But I'm calling it memory monitor right now, and it's got two classes in it. One of which I'm showing off called allocation size. And oh, my YouTube chat on screen looks broken. Really? Did I not? Unable to connect to the chat. Retry later. I mean, the URL is going to be the same, right? Did that kick it? How do I get refresh cache of current page? There we go. How's that? Okay, so what we have here, did it really not? Oh, I'm just scrolled up. Okay, so these are the numbers we can compare. So the first set here is 247, 33, and 8. And that's for the text. Whereas in our example, it was 1600, 1, and then there was 5 less than 8, and there was 4 less than 16 blocks. So this confirms that in the text case, we've confirmed we are allocating fewer things and we're allocating smaller things. And there's been some optimizations that I'll talk about in just a bit. I'll show you how I got here, because I wasn't actually to this point. I had achieved the like fewer large allocation stuff with my switches, but I was actually allocating a ton of small blocks. And I'll show you that in just a second. And then this is the JSON stuff for both parsing and fetching, which I've split out into two things here. So we're still under, we could just add these together. So we're like 340 allocations of one block. And then the largest is 8 blocks, and we're doing 5 of those. So that's exactly the same as here. And for 4, we're doing 16. So we're actually doing a few more 4 level ones. And 84 is identical. But we're doing about half as many single byte, and we're not doing any of the big ones, which is exactly what we wanted. So the big ones are really troublesome because if your heap's really fragmented, you may not have like a large stretch that you can place anything. So like trying to keep everything small means that it's much more likely that you can allocate it. And these larger ones don't surprise me at all, because there's actually, if we just look in here, like this big long string is going to be allocated as a single thing. So like we can count how many bytes this is, but like it's got to be a single object. So we're going to have these kind of top few ones be pretty standard because we are allocating all the structures still. Yeah, so that's good. Now, I said that it wasn't this great when I first started. So let me point some of the things out. Let's first talk about, so that's what allocation size can do, is that it can give you insight about a particular section of code, how many allocations and what sizes they are. So it kind of like benchmark for this reason. The second thing I added was, and if Jeff is watching, I'll have him do the review for me. So the second thing I added was allocation alarm. And this is an idea I had where if you want to find the thing that is causing the allocation, you can set an allocation alarm, and it will raise an exception where the allocation is happening. So let me just demonstrate that. So what we can do in our code.py, say we want to find one of these. Let's not look at parsing. Let's actually look at the HTTP GET. And hopefully we won't get our things in a bad state. But what I've been doing is I call it no allocations equals memory monitor allocation alarm. And then you can optionally give it a minimum block size. So if you want to find just the large ones, you can do that. I think that you actually may want we actually might want the reverse, where we actually like ignore the large ones because the large ones are actually okay. So I'm playing around with that idea. But now what we can do is we can just swap out for no allocations, and we will get an exception the very first time that an allocation occurs when we're doing the HTTP GET. So let's watch that. And it is on the JSON one, so it'll take a little time. Yeah, Jeff, you're definitely going to be my reviewer. So here's what happens. So you get a code.py attempt to allocate one block. And this one is not that helpful in particular, because we're just doing this HTTP GET JSON URL. Like, it only gave us down to the allocation here, which is kind of unfortunate. Let me show you. Let's figure out what this is. I'm kind of curious. So one thing that you can do is we have that set up. So I'm going to disconnect. And this is what I was doing yesterday, is something in the C code is doing an allocation. I don't know what. And so I'm going to detach my USB. And what I'm going to do is I'm going to reconnect through the debugger. So if I just go here, so I don't have USB on. Oh, it's not working because my J-Link is off. Oh, and it's unplugged. Plug my J-Link in. Redo this so it can talk to the J-Link. Let me restart. Actually, let me not do that right now, because what I do have to do is in allocation alarm. So this is shared bindings. Here's shared module, memory monitor, allocation alarm. I have this commented out, but it's a breakpoint. So this is the point where every time an allocation occurs, the GC file will call this allocation with the block count. And then we look through the list of all the alarms that we have active. And if it matches, then we pause the alarm, because we may allocate later. We may allocate when we raise the exception. So we want to make sure that our alarm triggers once and then we're done. And then we alert count plus because we're going to check the other ones and turn any of the other ones off as well. And then if there are alert counts greater than 0, then we'll raise the exception. So I just added the breakpoint in here. This is the assembly breakpoint instruction. Dan has seen that end up in my code sometimes. But it's a way for me to get like the C stack equivalent of the Python stack. So if I just save, and I have this helper called reload debug. If you want my GDB in it, just ping me on Discord and I'll send it your way. But it basically runs make for the board that so it pulls out the board from the file that I started GDB with. So it'll rebuild it and then reload it all in one step. So we'll just wait for that. And once we run it, we should be able to, it'll run all that code up high. We don't want to connect to it because the moment you hit a breakpoint, your USB gets really unhappy. So it loaded, and now we hit continue, and it's going to take a little while because it's going to do like the Wi-Fi scan and connect to the Wi-Fi and everything. But then it should break during the allocation that it's seeing. There was a couple things that I found when I was doing this yesterday. One was that calling functions may actually cause an allocation on the heap if the amount of state the function needs to execute is like larger than 44 bytes, is what it looked like. And so this thing actually triggers on all these internal allocations as well. So that was one. And the way that I fix that is Damien, like 2 years ago, introduced this thing called the Pi stack into MicroPython. And it's actually in the version that we're based on, which is great. But the Pi stack is basically the way that it originally worked is that if it was less than 44 bytes, it would just actually put it on the C stack and use it there. But if it was greater, like you didn't want to grow the stack, so we would put it in the heap. But allocating to the heap can be kind of slow. So he introduced the C stack, which hopefully this works. He introduced the Pi stack. So basically, whenever you call a function or need scoped allocations for MicroPython stuff, like there's a separate region of memory. I set it to 1K, which I think is about right. I set it to 1K where that it will allocate all of the code state for function calls and things on a separate place instead. So I don't know why it hasn't broken yet, but the LED is solid green, so it's still running. I'll rerun it in just a sec if it doesn't go. Yeah, so the Pi stack looks really interesting because I wasn't aware that like sometimes function calls will trigger those allocations. And the nice thing about having this separate region for that data is that we can actually place that in like fast memory. So in the case of the ESP32S2, like where we have a ton of memory, but that memory is on an external chip, it's actually can be kind of slow to access. So I would rather put the Pi stack on the internal memory and have it be quickly accessible, and then like the bulk heap can still live in the external memory. I don't know why this isn't. Oh, something's unhappy. Huh. J-Link is not. What happened? J-Link is not happy. Yeah, so the Pi stack looks really interesting. I could put it in the repository. One of the reasons I don't really want to do that is because of the port number for your debugger is in my GDB init, and that depends. It changes whether you're using OpenOCD or J-Link. I think I do actually have like a. I've already shared it as a gist. Let me see. See all of your gists. It hasn't changed. Wow. Here it is. Here's my GDB init. Yeah, it's just a little like I have paths hard coded in it and stuff. It's meant more as an example than something you can use out of the box. Which maybe some of that could be moved generically, like the make stuff. All right, let's reconnect here. I don't know why I got so unhappy. All right, TX is blinking. It looks like it's going. That looks happy. Yeah, so I am enabling the PyStack, and it should actually speed things up for like large function calls. Yeah, the SVD stuff. So if you look in my GDB init, and I can actually I think I have it here. SVD 51J. Except I hit 2. So SVD files are like this XML format that basically catalogs all of the registers of a device. So now I could do like SVD circom 0, and it tells me like all the different modes or clusters. So if I want to see like the SPI-M version of it, now I can see all of the different things. And yeah, so the SVD stuff's really handy. I like it a lot, and it's actually implemented in Python. So if you notice, I'm running like the version of GDB that has Python embedded, which is kind of wild. I was talking with Jimmo, who works on MicroPython, and I was like, it would be really cool if we had like a helper Python script for GDB where like here right now I can get a backtrace, but it's like the C version of the backtrace. It would be super cool if I could get like do PBT, right, and then get the like Python backtrace for where I am. Would be really neat. But yeah. So let's see. So we're in np setup code state np obj new dict. So let's just pull that up and take a gander at it. This is something I did run into, which is depending on how you put your arguments in your function call, you might actually, like if you call that function, you might trigger an allocation. And the culprit that I found yesterday was I actually had an old MPY file for bus device where it used star keyword args and star or a star exe or something. Like it packed all of the parameters into a tuple, and so like calling that was creating a tuple, which was unfortunate. And this is like very, very much in the same code as I was yesterday. Let's see. Fun BC call setup code says BC272. I was like totally right in this code yesterday. And I think this is something that we're going to need a guide for, like with this tool of like, oh yeah, if it doesn't make any sense, like it's probably because it's happening under the hood. Yeah, so this is saying if the scope has keyword arguments, then we need to provide it a dictionary. So we're calling, let's just look at the Python code again. So we're calling HTTP GET. And if we pull up, I think I have it here, requests. So we're calling requests and we're calling GET. Haha! So this is the thing. This is exactly what I was talking about. Star key W. What this is doing is that it's taking all the keyword args you give it and constructing a dictionary out of it for you. So every time you call that, you're going to do create a dictionary, pass it into request. So this star star here actually undoes that dictionary and does it as keyword arguments down to request. Is that something that I actually want to optimize though? Right. We talked about premature optimization, and I think the answer is no. Like one thing we could do is we could just copy all these. And that would be a runtime memory trade-off versus a memory trade-off for the functions themselves, like when you import them, because I'm sure that there's a little bit of data, like extra data that you have to store for all these different arguments. So yeah, that is something we could think about. But the reality is that like that's only going to happen once per get call, right? And that's not that interesting. So the other feature I was thinking about adding on the stream, which is exactly kind of what I'm hitting here, is that like if I look at that number, where's the number? I have too many windows always. If I look at the number here, like 700, like one call that happens because of that star star keyword is like not my problem, right? Like the very first thing it does is not actually my problem. I want to find the thing that happens like 700 times. And the way that I thought about doing that is actually modifying. Let's just do this. Anybody have ideas about how to do this? What I'm going to do is in shared bindings, I'm going to add a new function, and I'm going to call it ignore. And it's going to... Where should I put it? Should I put it as a function? I was going to call it ignore. So you would be able to say no allocations, ignore 1. And then like that first one that hits will just decrement a counter and basically allow you to skip over the ones. Like we just figured out why that occurs. Not super concerned about it. Let me just skip over it. The other thing you could do instead is actually just move where you're kind of putting that width block, narrowing the scope of and honing it down that way. Maybe that's a better way to do it. I gotta update these comments, they're wrong. What do you think? We could have a property that says ignore, but I kind of like the idea of it like only lasting 1. That's what I like. Let's just do that. Okay, so we're, oh, I hit the wrong button. Let's add ignore here. So it's actually going to take a count. It's going to return itself because I want to be able to put it in. This is probably not great API design, but add set ignore. So enter is not going to change ignore, but I think I want exit to actually set it back to 0. Like by default, I want it to be pretty aggressive. I want kind of like the ignore count to be scoped as well. So we're going to do set ignore. This is not going to resume. Sets the number of applicable applications to ignore. And then ignore here. I'm doing it the manual way, I'm sorry. I know it bothers you. I could like do a find and replace, but it's not my bottleneck. I need to get... How do I parse an int? Count equals... DCD says, since you want to catch the high offenders, example the 700, is there a way to classify the allocations and dump out enough information that a Pareto chart can be created? Would profiling help? Yeah, I think that's the other way to go for sure. And I thought about it. I thought about doing it natively like this, but I don't actually know how to get the backtrace without just raising an exception. So yeah, theoretically, I could make an object like this that counts like per like the call stack for every allocation. But I don't actually know how to figure that out, so I haven't done it. So if you want to figure out how to do that in MicroPython, that would be awesome. I mean, I'm sure there's a way to do it because exceptions do it, but I don't know how to do it myself. But yeah, if you want to find like the hotspots. And the other way to do it is like if you watched my stream from like 3 years ago, where I talk about the setup where instead of like right now, I'm just incrementing a counter when an allocation happens. I had it tie to GDB, dump the backtrace, and spit it out to a file, and it actually dumped the entire RAM as well. So I generated like those like animations of all the allocations and how they happen. So that's the other way to do it, and that's something that you can drive because that's literally just logging every allocation and the state of the memory at every allocation, which is amazing. It's awesome that like I can dump 32K of RAM every allocation and then analyze it on my computer with gigabytes of RAM. Like it's super cool. I love that about this. So yeah, that's an option. Memory monitor is a good place to put it. It's more complicated than what I'm going for. I like the idea of being able to assert that like this code allocates nothing, which what I was working on yesterday as I was working on the receive into version of socket is I put a no allocations thing in that call, or the read into call from Adafruit requests. And when I first did that, I was printing out a lot because as we know, like the JSON native module calls it to get every byte, and it was doing 34 allocations per get me 1 byte for JSON, which is insane. 34 allocations. And I did a number of optimizations. PyStack was one of them. There was a couple cases where, there's just a number of things that I ran down yesterday to get that from 34 to 0. And make it a lot more efficient. And I can go over that a little bit later. But let me do this. I wanted to show, like, I was hoping that we could find one of those as well that we could actually optimize out. So I want to add this ignore count thing. I think I changed everything, but I need to figure out how to parse an int. Do I do it here at all? I don't think I do. I know how to return an int off the top of my head, but I don't know how to parse one. So I think it's an basically, like, you're getting in small int. Is small int. So there's like two types of ints, because small ints are ones that fit in pointers. And here we go. This is what we want. So this takes in an object and then just gives us an int out. And it looks like, because there's a maybe variant, it means that if it's not an int, it'll raise an exception, which is totally okay with me. That it does like the type checking as well. So, I'm in the wrong file. I'll just put it here. Don't want this on allocation size. Luckily, they're very related. So I just, oh, look, I even added a to-do. And this can go with me as well. Enter exit, set it back to 0. Count, get count, set ignore. And then just all of these allocation sizes need to be changed to allocation alarm. Like that. And I should also check that it's greater than greater than 0. Or greater than at least 0. And that might actually be introducing a new argument checking. So fun. But now that we know that it's at least 0 is good. And then we're going to add it here. Void. Set ignore. Oh, and we should actually cast it. And now we implement it in shared module. Sorry, Jeff, if I'm not giving you enough of how I GDB things. Self count equals count. And then now what we do is we, if block count, blah, 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 we can leave this breakpoint. But we can say that if alarm, or yeah, if alarm count is greater than 0, we alarm count, so minus minus. On the C code, you had the less than pointing to one side, and on the commentary, you had it pointing the other way. Okay. Else. I assume that was in the other file for the error message. So we don't remove it, we don't breakpoint if we hit it. And that's actually kind of, well, let's remove it. Let's comment the breakpoint back out because we're going to want to change it. All right, I think that's what we want. We do need to add np-int t count as well. Get it building and check my directions. Must be greater than or equal to 0. Yeah, this is correct. So it's saying like if minimum block count is less than 1, then tell you that it must be greater than or equal to 1. So it's okay that they're the reverse. One is like finding the error condition and one is saying what the valid condition is. Minimum block count. Then I think we need self thing too. Oh no, I'm passing self in straight away. That should work. Sorry about the leaf blower. Last time it was the like they just put in the new driveway across the street and they're blowing it off. Incompatible pointer. Okay, that's because this is a 1 here. So this is a macro that is declaring another object that wraps the function object, and I increase the number of arguments from 1 to 2. So I need to change that to 2. And that should work. Closer. In shared bindings 110, self in is undeclared. 110. Set ignore. Exit. So that would be args 0. Which, yeah, I guess if there's no allocations, your count could be high still. Or like if you never reach the number that you're going for. Are there any questions about this stuff? Is this exciting? Is it useful? Is it a bad idea? I think it's pretty powerful. That's my bias. I'm curious to see if we see like code like speed ups and stuff. Hi, Thomas. Right. I'm just gonna run it without turning on USB just to make sure that it seems to work. Looks like it's okay. I'm not using it at all. All right, I'm gonna give it a shot. Turned on my USB. Connect to screen. Control D, see what's happening. Huh? That A2 says, nope, very cool. What are other places that it is assumed that optimization would be a nice thing? That's a good question. What are other things that we should target for optimizations? You know, the best place to start is just anything that happens a lot, right? That's why I was very concerned about receive into, is that like it happens every byte of the JSON thing that you're processing. So generally, like, constructors aren't that interesting. Okay, so we got to the place that we were before. So let's just see. I mean, one thing I'd really like to optimize as well is just library size. So like after you import a library, how much space does it take up? And I think there is a bug there as well where we do a collect after the library is imported and moved to long-lived, but I think there are some stack pointers that are still pointing to the old stuff. That means that when we do that collect, we're not actually collecting everything that we should be or that we could be. Okay, so for code.py, where's our... No. Okay, so no allocations, ignore 1. Let's see what... So we should get a different stack trace here. And basically it allows us to like get further along and see what changes. The hope is that we'll hit one that's actually a Python thing. Allocation alarm object has no attribute ignore. Great. I forgot to connect it up. Okay, so I'm just ejecting, turning off my USB because I'm connected to JLink. The moment that I Control C here, my USB is going to be very unhappy. So now I can Control C and like not everything starts to die. Let's go back to allocation alarm. And we just need to add another entry here. Like I think we connected it all up correctly. I think all the code is right. This is very much my workflow when I'm working with GDB. I'll basically use GDB in cases where I need more insights into the sea level stuff. Or if I'm like hard crashing or seg faulting, that sort of thing. So if you get like a safe mode, GDB is a great way to do it because you can breakpoint on the function call to reset into safe mode. So you won't actually go all the way back into safe mode. You'll just get the backtrace of why you got there usually. Which I hit when I was doing this work because I was not initializing the lists of like all the active allocation alarms and allocation sizes. I wasn't initializing that, which was causing it a little bit of chaos on reset. To the degree that it like looked like my file system was corrupted, like the CircuitPython file system was corrupted and stuff. All right, it's loading. Let's run it. And I'll just turn on USB. It's possible it'll crash, and now maybe I'll demonstrate what I just talked about. What am I doing? It's going. All right, look at that. So we got further. So now we're in, so this is the stack trace we saw. Now we're in get, now we're in request, line 396. So let's just take a look at that and see if we suspect that it's a problem. So 396. Well, that makes sense. So we're saying like, okay, if the headers are not there, then we're going to create a headers dictionary. So yep, that's an allocation. So I think now what I'm imagining is you just, okay, go here and make it a 2 and run your code. All of you who do like standard C stuff and have those tools of like profilers and all that stuff are like, oh my gosh, that's so rudimentary. Yeah, it is. But it's useful. 399. So now we're doing URL split. We're doing a replace. So replace here is also generating a new string and then assigning it back to path. Is there an in? No, there can't be a replace that works inline because it's expanding one substring to a substring of 3 characters. So like that'll cause an allocation. So I think there's actually 2 here or 5 here. So split is going to create 4 new strings and a tuple, and then that tuple gets unpacked into those 4 spots. So I think should we try this? Is this too boring? This will lead us on 399 still. We can like count. And like I said, the other thing we could do is we could actually like move where our with statement is. So like that might be a better option. Because we can look at here and say like, okay, there's a bunch of allocations here. There's this, blah, blah, blah. Like maybe we want it on get socket. Maybe we want it on like send is going to cause an allocation, but maybe once we like maybe this send, and like maybe we want to make send itself not allocate. So you might allocate to give it something, but after you do that, you don't want anything, right? Another optimization we could do is like the reverse of the JSON optimization we already did. So like dump S is going to create one giant string and then send it all. which you kind of have to do given that you have to give it content length, I think. So like data here, you have to like measure how long it is. And so that's kind of like, you could do two passes where it's just like, hey, how long is this going to be? And then give it to me as you're going. But yeah, I think that's all I want to cover on like how this works. And then let me just go through this and just point out some of the things that I did change. So if we're looking in socket pool, so this is the like new replacement version of ESP32 SPI socket. And socket pool, I think is going to be a module that I also provide a module that I can provide natively from the ESP32S2. DCD asks in Discord, what other profiling tools are available, either in the C or the Python side, developer level or user level profiling? Not much, honestly, that I've seen. There was this really cool, backing up is on my side. The landscapers, they're just so close to done. But they're not quite done yet. And now they have to back out of the driveway. There was this really cool Python profile visualization thing that I can't remember what it's called. But it would be great to support some of those tools, but we just don't. There's some good articles also I saw about like profiling with ARM and using like ARM tooling to take program counter samples and stuff. But like I said, there's kind of a disconnect between like profiling on the C side and then being able to profile, like understand where you are in Python code when you took those snapshots. So yeah, not great options. It's all like pretty new for us, right? Like, I think memory optimization is generally more important for us because it allows you to do larger projects. Performance-wise, Jeff was doing some basic optimizations. Like we made the performance of CircuitPython. I made the performance of CircuitPython worse when I did all the low power stuff because I had to like remove this check that prevented the background stuff from running at like a 1 millisecond frequency or so. But Jeffrey did how that's done, and now it's done actually a bit better than it was before. And the performance is like pretty on par with what it was, or just a bit better. But yeah, it's pretty early. We don't have a lot of good options. I've mostly been focused on optimizing memory because memory allocations cause CPU time problems, right? Like we had this bad case where we found this like pathological like tight for loop that was only allocating 2 blocks or more, and like originally the version of like the allocator that we had would like keep track of like the next place to look, but that pointer when it was doing the allocations only got advanced if it was a 1 byte block, because then it knew it was tightly packed. But if you have this like pathological case where you're never allocating a 1 byte block, you're always allocating 2 or more, like that pointer never got updated, and therefore like you had to look further and further and further every time you were doing that like 2+ size allocation. We fixed that. It should be a lot better now. I think it still happens if you manage to get like, a loop with just like 8 block allocations in it. You may still hit it, but that was like kind of a crazy thing. So allocating takes time, and then like the way that we free stuff, right, is like if you're allocating and allocating, you're just building up all this memory next to each other, and like at some point when we run out, we've got to go through this like very expensive process to like look at all memory, figure out everything that's still live within that range, and then delete it all and like do all this housekeeping. So you actually win kind of twice when you optimize for allocation count, because you optimize basically like how much memory you actually need, but you're also optimizing like churn on that. So like the CPU overhead of doing allocations and cleaning up those allocations later. So I think like memory optimization and these tools are a really good place to start. Um, and the allocation size thing, being able to find that like you are allocating large things is interesting too, because like when people run out of memory, they'll run GC memfree and they'll be like, I have like plenty of space. It's like, well, you do, but there's like one thing that ended up in the middle that segmented that long consecutive thing. And there's lots of ways that people have come up with to fix those sorts of things, but we're still pretty rudimentary in how we do it. Um, yeah. Yeah, it's stuff I'm interested in, but at the end of the day, also, another reason to worry less about performance optimization is like execution speed, is simply because like with Python, you're never going to hit C speeds, right? Like we can optimize we can optimize the Python execution all we want, but at the end of the day, it's much easier to just write C to do the same thing, and then it'll be faster than I think you could ever achieve with Python. Like some people might disagree with me, but like the effort to get Python to the point where it's just as fast as C is like incredible. Whereas you could just add a C module pretty easily and get there pretty quickly instead. So I think there's that balance of like you really don't like performance. Python side is actually not that important. It's more like memory optimization is like you simply can do things that you couldn't do before because of the way that the allocation patterns happened. Yeah, pretty interesting. Okay, let's talk. Yeah, we're just about at time. So ask any other questions you have. I'm happy to stay later and answer them. But I have to figure out what I want to do next. But what I did want to talk about is just a couple other places that I had to optimize in order for receive into to be zero allocation. Let's see. So this send command get response, as it was originally in send command get response. Yeah, it calls this wait response command. As it was originally written, it would Fede2 says substitute C for Rust. If you want to get native Rust modules working in CircuitPython, sign me up. I'm on board. All I need is like one module that demonstrates how to do it, and then we can add more modules. Like I'm totally sold that Rust is the direction to go. It's just like having the time to get there. So what wait response command originally did is that it always allocated a list, and then it would allocate a bytes object for every parameter that was returned. So the way that it works is it reflects back the command you got, and then it tells you how many different parameters the response has. And then for every response, there's a length of it, and then it would allocate a byte array for every parameter that was responding with. So what I did is, instead of always allocating the list and then always allocating a byte array, I basically add a special case that is, we don't allocate the list until we know that we have more than one response. So that's what this is doing. It's actually two allocations. There's one allocation for the single element list, and then we multiply it by the number of responses we actually want. And the reason I'm okay to pay that cost is that I think the allocation that happens with the star is exactly the size I want. Whereas if you grow a list, it usually doubles in size every time you grow it. So that's just a trick that I think is okay. Um, but this is actually the common case for this call is that you only get one response, because it might just be like, yeah, I worked, or like, here's a number, like how much I get back. So it's actually very common for your response to be a single value. And then furthermore, I actually say, oh, if it's of 0 length, then I just leave the none in. But I also say that I only allocate the byte array to give back if the parameter is more than 1 byte, because a lot of the responses are also a single byte. And so it doesn't make sense for me to allocate a byte array of 1 and pass it back, because a byte array and an array and a list, they actually are 2 allocations. They're like one, like kind of like metadata object, and then they're just a consecutive list or consecutive allocation on top of that. And if you want to see more about this, I think that stream I did a few years ago is actually pretty good, because we have diagrams and stuff for it. Basically, I optimize this so that if you have a single byte response in one parameter, it just returns you exactly what you need, which actually simplifies a lot of these checks. So if we look in, basically, if you look at the diff, so here's an example that I've commented out, but like send command get response, and then we just want to like unpack so it's like sub 0, and then we get the value that we actually want. Like in this case, you just delete the 2 zeros and you already have the value that you want, and you didn't allocate anything just to get it out. In cases like this where it's just checking response code, again, like you're saving all those allocations too. So that was one thing I did. One of the other main things I had to do is I actually had to move away from, I had to stop doing enumerate, because enumerate allocates a tuple for every entry. So where did I added comments where I said don't enumerate. It might have been in requests. Yeah, maybe. Oh, yeah, here we go. So in send command, so this is the packing of the stuff in. There was an enumerate here that was like I comma param for in enumerate params, which is totally more readable, and Pylint is actually going to complain to me. But the problem is that for every parameter, it's allocating a tuple of the index and the value, and then it gets immediately unpacked by this statement here. So you're doing all of this like allocate it, unpack it, allocate it, unpack it, when you don't actually need it at all. So I just switched it to like iterate over the indices and get the values separately. And now I'm avoiding the allocation. Tashipu says, I thought that there was a hack in the MicroPython that made it not allocate a tuple if enumerate is used alone in a for loop. I was triggering on it, I think. We could test it. Actually, we have the technology here. So let's just try it. Let's remove this ignore. We'll just pause that, and I think I can call print. I'm trying to think of like, I can just do a for I c in enumerate JSON URL. Pass. Let's see what that does. Am I connected? Yeah. Yeah, there might have been a discussion about it, but it was never done. I was thinking about that, but it feels like a pretty special case. And like I said, generally it's okay to use, yeah. So that's in 128. But if we do, so that C is going to be a small int. So the other variant of this would be range of the length of the URL. And then C equals JSON URL of I. Like that's the equivalent. And that should pass, I think. Depends on what C is. Like if C is just a number, then it should be okay. Also, wouldn't it be better to iterate over the values with the for and manually increment the counter instead of retrieving the value every time? That's a different question. That I don't know. Like you're balancing the cost of doing the local increment versus the lookup cost, which is probably more expensive to do the lookup in the dictionary. But that seems a little bit... Whoa. Attempt to allocate 24 blocks. Why do we think that is? That's a lot of blocks. What happens if I just do pass? Why do you think it's 24 blocks? Like 24 blocks is a lot. Or am I... No, that's where I am. What is JSON URL of 0? Good night, Mark. Thanks for staying up the 2 hours. And thank you for being part of Mark DNS. Oh, okay. Yeah, we could try that. So it's H. But why is that doing a 24 block allocation? That's insane. Why would JSON URL sub I do a 24 block allocation? Anybody have any ideas? Does it have to like copy the string? Attempting to allocate 24 blocks. This is why premature optimization is dangerous, is because you find stuff like this perpetually. Like maybe it has to cast it to a different type and then take the subscript of it. Like maybe it has to take like an intern string, create a real string out of it, and then do it. Okay, let's comment this out and do what Deshipu is saying. I think it's safe to just ignore C. Let's see what that does. It depends on how the iterator works. $132. Ah, so this is attempting to do a 24 block allocation as well. Okay, let's wrap up soon, but I'm curious. So what I'm going to do is I'm going to uncomment the breakpoint and just see where from the C side where it is. Da, 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 da. Almost done. I think after the stream, I'm going to try splitting. Like, I have pretty good commits for all this stuff. So I'm going to try to get some of these committed to get PRs out to CircuitPython. And I want to just push my current state of the ESP and the request stuff to my GitHub, just on my branch, just so that it's not just on my local computer. But first, I want to see this, and then I'll stop streaming. So yeah, if you have any more questions. That talking about C and Rust says, I'm crappy with challenges, but this one sounds like a nice bite-sized one. I've been watching how they do it in CPython. There is actually Rust Python as well. Like somebody is re-implementing Python in Rust, which I was like, huh, I wonder if you could port that to basically like CircuitPython. Like use Rust Python. I think it's just called Rust Python. Yeah. Like latest commit 29 minutes ago. Their CI is failing, but Python 3 interpreter written in Rust. 3.5 greater than compatible. Run it in WebAssembly. Yeah, pretty interesting. Rust is neat. I like the idea of it. I've never sat down to learn it though. We've cribbed a lot of their community stuff from them. All right, well, we added the ignore count, which is cool. Let's just see what this string stuff is doing. MP map lookup. Dictionary store global. Ah, so maybe that's because of we need to, like, we could declare C outside of the for loop. Like we ran out of space, so we're having to redo it. Let's just try it. Get down the rabbit hole. So the question is, what happens if I just declare C outside of it? Problem is, then if it still allocates, then I'm curious again. So yeah, hopefully all these CircuitPython changes I'll get out today. And then I'll do the library ones just to my branches. But I gotta like delete a bunch of the stuff that I'm not using in the libraries. Okay. So I disabled the breakpoint and should be able to connect. And then in code.py should be able to do, whoop, too many windows. So outside of the width, I say C equals none. So that should get rid of the 24 block allocation. Like 24 blocks is a lot. But that's probably, like, it's probably 12 now. Oh, it's still doing it. Is that because of I? These are dangerous tools. One question I have for you, for folks is, oh, it worked. Yeah, so if I and C are declared outside of it, then it's fine. Let's try the other version. Do you think the memory monitor should be on by default? That's the question. And I probably not SAMD21 because it doesn't have room. But should we turn it on by default for everything else? I don't actually know how big it is. But right now I just have it where you just add per the board that you want to turn it on. Sweet. So this version works, and enumerate. Let's test enumerate once more. This should crash. If I'm right that optimization doesn't exist. Which I'm pretty sure. I removed it in 3 spots yesterday. Of course, like, the web server is going to go down on the very last time. I don't know why it takes so long sometimes. Yeah, I don't know. 32 asks, how much memory does add to the CPAC code? That I don't know. Oh, IC, not CI. It doesn't actually matter. I'm not doing anything with either of those. Oh, come on. Unhappy? I thought I made the library more reliable. They're always backing up. Oh dear. Yeah, there we go. It's attempting to allocate 1 block. So yeah, there is an allocation happening here. Okay. Let's call that a stream. Delon says, I feel like if it's not crazy hard to turn on and off, leaving it off by default is okay. Right. The super says, yeah, but you might get a weird bug later on if you build upon this. Yep, that's true. That should be IC. A reminder to back up my code. Yeah, totally, Kretschmar. That's definitely what the backup noise is. Okay, so that's what I've been working on. I think I covered most of what I've done. The plan going forward is really to take a look next week. I think next week at the libraries with fresh eyes, because I know that there's work there to be done. Like, I haven't tested HTTPS yet. I need to add that, and there's a lot of like commented code and stuff that I want to redo and stuff. So I think next week my goal is going to be getting the ESP32 SPI and the requests changes set and checked in. I think they'll probably be released as pre-release because pre-releases aren't included in the bundle, because I'll break other stuff that uses those. But then the core stuff, I should be able to get checked in pretty quickly. I think they're well segmented pieces of code, like the memory monitor stuff and the Pi stack stuff. And I added the ability to byte array to call find on it. I needed that for the changes I made to requests as well. So I think all those 3 things I should be able to get PRs out today, after I maybe take a break and go for a walk. So I should be able to get that out. And my goal is like really to wrap this stuff up and get back to the ESP32S2. And when I do that, it's going to be basically create socket pool, create SSL, create a Wi-Fi thing that mirrors the ESP32 SPI's structure and API, which is why I took this detour in the first place. And then once I can do that, then we'll have Wi-Fi, hopefully, on the ESP32S2. So that's where I want to I want to be pretty aggressive in getting back to that spot because I've spent enough time in ESP32 SPI land. But yeah, hopefully the memory monitor stuff is helpful. I think it is one of those things of like I just took a day and finally did it, and it's actually very helpful. So take a look out for PRs with that stuff. Try it. Let me know what you think. And that should be really cool. Thank you all for coming along this deep dive with me that I do every week. Thank you for your patience with the internet being a little shaky there for a little while. Glad that it came back and I could run these tests. Reminder, you should be able to get to Adafruit.com again. Please support them. They support me. They pay me to work on CircuitPython and all open source, all open discussion sorts of stuff. So they're great. Please support them. And join our Discord. The chats for like YouTube and Twitch and Twitter are going to go away because like they're only with the stream. But you can go to the URL adafru.it/discord to get on our Discord server, which stays around. Lots of cool folks, lots of different projects, lots of folks that can help you if you have trouble with stuff. So adafru.it/discord. And yeah, love to see you there. And I think next week should be normal. Keep an eye on the Adafruit blog and ping me on Discord if you have questions. But I think it should just be Friday again next week. So with that, thank you all. Have a great weekend. And for those of you who it is weekend, I know Australian folks are their Saturday morning. Thanks for spending your Saturday morning with me. I hope your weekend's good so far. So thanks, and we'll see you next week.